Polymers on farms have many uses, from the bottles used to feed lambs to the string used to tie goats. Polymer, specifically low-density polyethylene.
But what is low-density polyethylene? To go back to the basics, low-density polyethylene is a grade of polyethylene. Poly, of course, meaning many, so literally many ethylenes. Ethylene is the most popular plastic in the world and has widespread use across industries, all the way from children's toys to cosmetics packaging to military equipment like bulletproof vests, and of course, agriculture. Perhaps surprisingly for a plastic with such varied application, it has the most simplistic structure of all commercial polymers, and at its least complex, it is just a chain of carbon atoms each attached to two hydrogens. This linear structure without branches is known as high-density polyethylene, and due to its ability to closely pack together, the higher density makes for a rigid plastic. This is achieved through synthesis via a Ziegler-Natta catalyst, which decreases the amount of branching that occurs during polymerization and increases tacticity. This means that there is greater structural regularity and chains can fit together tighter, leading to a higher melting point and densities than if it was prepared by traditional methods. Low-density polyethylene, on the other hand, is the branched version of the same polymer and is synthesized via free radical polymerization. The initiator molecule is usually either AIBN or benzoyl peroxide, which split to create initiator fragments. The free radicals can then polymerize the ethylene monomers to give low-density polyethylene. Due to its branch structure, the chains cannot pack so tightly together, meaning its density is reduced and the plastic is less rigid and durable than high-density polyethylene. Because of their contrasting properties, the two plastics are used to make very different products, despite the fact that they are both ethylene, with a huge variety of common commercial uses across many different industries.
But today, I'm specifically interested in how they're implemented in farming, which is why I've come to a farm in sunny Wales to find out more.
Out of all the polymers, low-density polyethylene, specifically in a single-use film form, is perhaps used in the highest quantity, and certainly made up the majority of plastic usage that I witnessed on the farm that I worked on. Its main use is silage wrap. Silage is a fermented grass crop and is fed to livestock such as sheep and cows as a better alternative to hay, not to be confused with straw, which is inedible and mostly only used for bedding. One of the many advantages of silage is that it is harvested earlier in the year than hay, when the young green plant is more nutritious, and it's been shown that grass and alfalfa offer higher protein energy levels when they are made into silage as opposed to being made into hay. Unlike hay, it has much higher moisture content of 40 to 60% versus only 12%. This means that it does not have to be cut and laid out to dry in the fields in late summer as hay does, which of course requires a period of hot, dry weather, an issue in wetter climates such as the UK. Once dry, hay can be stored in bales in sheds, and it is this extremely low water content that keeps it fresh. However, due to silage being preserved via fermentation, it must be kept in a sealed, airtight environment, as exposure to oxygen will cause it to quickly compost and rot down to nothing. When silage was first invented relatively recently, to create this environment, it had to be buried underground in ditches, which required a dedicated area of land that could have been used for pasture and of course the initial labour of creating this ditch. Most farmers could not afford this additional usage of labour and land, and even if they could, it seemed an unappealing and unnecessary swap, as hay had always worked perfectly well and silage was a new and potentially unreliable invention. This meant that hay was used by the vast majority of UK farmers until at least the mid-20th century. The introduction of plastic meant that silage could be stored in skips and heaps and covered by weighed down sheeting of low-density polyethylene, making it immediately much more manageable and accessible. And even more recently, advances in machinery mean that it can be individually wrapped and stored as bales. This allows farmers to have a feed that isn't reliant on dry summer weather, doesn't need dedicated sheltered storage space such as a barn, as the waterproof plastic means that it can be kept outside, and is also highly transportable. This creates the additional benefit of most farmers not even having to make their own silage, so that land that would have had to have been dedicated to cultivating the crop can instead be pastured and grazed by more livestock. Unlike low-density polyethylene, which structures lends itself to thin, flexible sheets of plastic, the contrasting structure of high-density polyethylene means that it is usually extruded into rigid and semi-rigid products such as lightweight buckets and containers, thick films, and protective bale nets. Polymers are completely integrated into agriculture and are essential for the function of the majority, if not all, farms today. However, the overarching downside when talking about plastics will always be the amount of waste produced, especially with single-use plastics such as low-density polyethylene silage wrap. When talking about reducing plastic waste, agriculture raises its own unique set of problems, because opposed to single-use plastic that is used for convenience rather than necessity, such as plastic wrap and shopping bags, many polymers have become absolutely essential to farming, and by extension, production of all of our food. This means that rather than eliminating plastics, creating a closed recycling loop is what is often proposed as a hopeful solution. Unfortunately, despite polyethylene being highly recyclable, the majority of polyethylene used on farms ends up in landfill. Because recycling companies are paid by weight, most will refuse to take large, thin buckets of high-density polyethylene as it takes up a large amount of limited lorry space and is very lightweight. Fortunately, if their local recycling company refuses to take these buckets, there's nothing the farmers can do, and while they can reuse them briefly, they will eventually end up in landfill. Low-density polyethylene single-use silage wrap is good in this regard, as it can be easily packed down so that there is a better volume to weight ratio. And so most recycling companies do take in LDPE. The main issue with recycling agroplastics is how contaminated they are, with build-up of biomass, mud, and chemical fertilizer, causing them to need to go through a 3-stage washing process when they are being recycled. This lengthy processing, of course, raises costs, and when it's so cheap to make polymers, there is no incentive for recycling. However, books could be written about that topic alone, so sadly, I must refrain from discussing it any further today. The dawn of plastics was completely revolutionary to many industries, and agriculture is not excluded. If you think about the last meal you ate, polymers were no doubt involved in every step of the production, from fertilizers in the field to the tractors used to harvest the crops, to the bags that it was stored in, to containers it was transported in, finally the packaging on the shelves, and even more steps if the product was meat. Thank you for watching my brief introduction into polymers in farming. I hope you enjoyed.